Last Christmas, I made 1911 for myself as a little Christmas present. It's machined from solid bar stock, both slide and frame, and a couple of the accessory components. I had a great deal of fun making it, and it was extraordinarily satisfying to pull off. So, great pistol to shoot. I really enjoy it, but it's in 45 ACP, and in terms of ammunition expense, that's one of the more expensive pistol calibers at the moment. So I had some free time this summer and wanted to make a new gun, but in 9mm, which is a little cheaper to shoot. So I really like the 1911 platform and wanted to stay with that. And when you go to 1911s and 9mm, you have the option of going to what's called a double stack or high capacity 1911. There's a trade name for them called a 2011, sort of like Kleenex or Xerox. Technically, only one company makes 2011s, but everyone sort of calls them that anyway. So for those of you who follow me for machining content and don't know a lot about guns, a 1911 takes a magazine that looks like this, and it holds its bullets in a single file fashion. This magazine holds 8 45 ACP rounds. The 2011 I made takes what's called a double stack magazine, and once you get past the funnel here, the bullets are held in a herringbone fashion of sorts, and this magazine, which is the same length, holds 18 9mm bullets. So in order to accomplish that, the hole in the gun where the magazine goes is quite a bit bigger. So this is the 1911. You can see how narrow the slot is, and then this is the 2011. Despite that, though, the width of the grip and length of the grip is the same, but this one's a little more squared off, and this one's a little more oval. People have their preferences. I find this to be a little more comfortable, but they're both very, very shootable pistols. And what I mean by that is when you present the pistol to your eye, the sights tend to line right up. And that has more to do with the grip angle and the way it sits in your hand than necessarily the width or the corners of the grip. So on my 2011, I didn't want to have to coat the components after I made them. So I opted for a stainless steel slide and barrel and hardware, but I made the frame from a copper alloy. And the reason I did that is as a die maker, I see just what you can get away with this stuff. I use it in a lot of sliding applications at very high speeds with very high loads, and it's a super impressive alloy. It's got higher hardness than say 4140, which is a very common alloy for like gun frames. Has better indentation resistance, and that's really important on a 2011. There's a feature called a vertical impact surface where the barrel cams back and stops on, and to be able to withstand that is useful. It has better wear resistance, which is good for the guide rails, and better galling resistance, which means this is going to be a very slippery slide, and it's going to cycle very smoothly. Not only is that kind of a mark of quality, it feels very nice and sounds very nice, must be nice. But the theory there is as the lubrication dries up in long strings of firing, it can withstand failure a little better than a gun that might start to gall or jam up when it gets dry. So I'm very happy I went with the copper alloy. When I was planning this, I did do some thermal expansion calculations to make sure it wasn't going to bind up as it got hot, and all that looked good. The one unintended consequence, though, is being copper based, it does conduct heat very well, and so when doing long strings of firing, I feel like it gets hotter faster than a steel frame gun does. But I used to shoot a lot of P7 pistols, and they're one of the hottest pistols I could think of, so it's not a problem for me, but it did kind of, I was a little disappointed I didn't think that was going to happen. So now onto the actual gun. As I learned with my 1911, when I made a video, you can't show machining on YouTube, and I didn't know that at the time, but I do now. So I can't show any of this getting cut, but I can kind of talk about it. And like the 1911, the first part of the process is creating the CAD model. That's probably the thing I get asked most is where do you get the CAD models for these? So the Army Arsenal drawings for the 1911 are a very good starting point, as well as the Kuhnhausen shop manuals. These are a must for any 1911, 2011 related project. The Volume 2 edition is going to have everything you need to know, tolerance, fit-wise, for a lot of the major systems. And you can use that to really build out your CAD models in conjunction with the ordnance drawings. Once you have what's a standard 1911 model made, you can then tailor it to suit what you're doing. Say you do want a 1911, but like me, you wanted a flared magwell or a larger HK style trigger guard. You have those options at that stage, but if you want to go the 2011 route, you have to modify the grip area to accept the 2011 grip module. I did not have access to the 2011 drawings, so I instead just bought the grip module and kind of worked backwards from there. And it came out fine. All the other parts have a lot of commonality with the 1911. Now, so once you have your CAD models, we're into the manufacturing. The slide's the same as the 1911. So if you saw my video, you have a pretty good sense of how that went down on the 1911. Manufacturing the frame, significantly easier. And that's kind of why I wanted to make this video. The manufacturability of this really impressed me. So on the 1911 frame, I made mine from solid stock. And as you can see, there's a lot of stock to remove there. The reason I had to go solid stock is because I wanted the flared magwell and the different trigger guard. You can, as you know, even I could buy like a 1911 casting or a forging. You can machine it from that if you want. It would be much more near net. Or if you're doing a lot and you're from solid stock, you could have a big plate, water jet or laser cut or whatever, into a pistol shape, and that'll cut down on the amount of metal removal you'll do. If you want to see more about how a traditional looking 1911 is made from a forging, there is a channel called Spardella Arms, and the owner, Neil, does a fantastic job at very openly sharing how he makes his 1911s, and I think he does a top-notch job. So if you're curious, give him a check out. So now on to my 2011. I used a piece of copper material that I put a dovetail on, and I held onto that dovetail, and then it went into the fourth axis, and you're able to flip it around and hit both sides and hit some of the odd angles. Like the 1911, there are a few, like the hole for the magazine well, it's angled, but unlike the 1911, it does not need broached. There's accommodations for a 3mm end mill to get in there, and you can just mill the magazine well cut out right to size. The disconnector hole is also on an odd angle, but if you remember on the 1911, there's a counterbore on the underside that you can either counter drill. So like typically on a 1911, you'd take a long drill and you'd come in through the magwell and you'd go all the way down to counter drill the counterbore on the other side of this disconnector hole. Not a huge deal, but it is what I consider a feature-specific tool, and that does get a little frustrating when you're doing something like the 1911 because there are so many feature-specific tools. And you just have like a huge tool library of these odd little form tools and drill bits that just do one thing. The 2011 gets away from a good bit of that. Like the counterbore on the opposite side of the disconnector, it's shallow enough that you could just get in there with a regular end mill to cut it. And the other one that I really enjoyed is the area that the guide rails would be, where the magazine is, needed cleared out because the magazine's so much wider than the 1911. What that creates, though, is an opportunity to where the top of the notch for the slide stop is now open. So there's this little bridge of material here on the 1911 that actually a lot of gunsmiths cut because it's prone to cracking on higher power cartridges. But it's not there on the 2011. So instead of having this odd little pocket that you have to cut and square up the corners on or broach, you can just take a 4mm or 3/16 end mill and take 2 passes through there. It's all of a sudden very easy to cut. And there's a lot of stuff like that. It just becomes significantly easier to deal with. And then the stock shape, you have a relatively small piece of stock. Metal removal is not that big a deal. But what the real power there is, in my mind, is it can now be made from round bar. An 1 3/4 round bar accommodates this part shape. And when you're buying material, and say it's something specific like a weird copper alloy, round bar is oftentimes the easiest way to get your hands on it, and pound for pound, it's the cheapest way to buy most materials. Anytime I see provisions for round bar, I get very excited, because not only is it easier sourcing the material and sawing the material, you also have the option to bar feed these round bars in 12-foot lengths into what's called a mill turn or a multitask center. And then all of a sudden your productivity can really skyrocket, because a mill turn goes from round bar stock to finished frame in one machining operation. And there are people doing that. And I don't want to undermine or marginalize the amount of process engineering that goes into that, but you're using standard work holding to hold the bar stock as it comes into the machine. The second operation grippers are custom, but probably easy to, they're rudimentary, if we're being honest. It's just jaws on a self-centering vise. And then you probably have some sort of robot to pull it out of the machine, but again, it's going to use a very basic set of jaws. Whereas if you're robotically feeding a forging like this into a CNC machining center, you're going to need some sort of automatic clamping fixture in the machining center. You're going to probably have custom grippers on the robot. And feeding forgings can be very unreliable. It's a big challenge. And so I think making it from round bar is just a lot smaller of a hurdle to overcome than, say, forgings. So I'm always very, very excited when I see round bar as an option. As far as my pistol, I did most of my work held on by the dovetail and my 4th axis, and I had a vertical, and then on the 4th axis is an operation, and then I had just a fixture that it bolted into for the final op. No broaching whatsoever. You could do a 2011 with, if you're making both the grip and the frame. I just made the frame. But you could do it with just having to broach the trigger track, whereas you have 3, sometimes 4 broaching operations on a 1911. And if you watched my 1911 video, the broaching can be quite intense. And so to get rid of a lot of that broaching is really powerful. So there are even high capacity 1911, 2011 type designs that get rid of the trigger broaching. Wilson Combat, for example, mills their trigger track and then just puts some fillets on the trigger so it fits right in there. Not only is it an evolution in how many bullets it can carry, but the 2011 or high capacity 1911 is just a huge step forward in how to manufacture these guns. And I just wanted to share that. So thank you for watching. I know a lot of you like seeing machining content, but I just couldn't really do it with this and keep the video on the channel. So this will have to do. But yeah, here's the gun. That copper alloy actually isn't polished. If you look real close, you can still see the feed lines. It's got enough nickel in it that it really shines up. And then the end of it, this does not have a bushing. The barrel is bushed inside the slide. And then it has what's called a ribbed barrel. And that's nice because when I get the front sight on there, the front sight isn't reciprocating. So if you're, when I use a red dot, I kind of keep the sights in the picture still. And it's kind of like a front sight tracker. It just not reciprocating helps you keep the gun on target, in my opinion. And also, if I wanted to port it, it's a lot easier to put porting holes in that rib. I put 2 compound chamfers on the slide. You can see this one and this one. That kind of blend into the ribbed barrel, and that kind of points an arrow to the front of the gun. A lot of older 1911s, they'd put serrations on the top, and they would kind of stop them and slowly form an arrow point with them. And that's so, like, as you're bringing your eye out on the sight, you have like this arrow pointing to the front of the gun. Does it do anything? Probably not. Does it look cool? Yeah, sure. And I just I wanted my version of that, I guess. Compared to my 1911, I did put not only more front cocking serrations on, and I never used to like front cocking serrations, but when I started using red dots, I find them to be more important. Not only did I put more on, but I brought them up the side of the gun too. I find gripping right there, it's you get a lot of traction. So, and then the dust cover, I didn't have the pick rail go all the way in. I like how the dust cover is kind of squared off, and you don't see the groove from the Picatinny track. So, then I went with silicon carbide grip tape. Didn't do an amazing job getting it on there, but I don't know, as a die maker, I use a lot of silicon carbide sandpaper, so I thought, why not just use it as my grip? But otherwise, yeah, really nice 2011. Super happy I made it. So I wanted to kind of do a better job of explaining how much easier some of these features get. So if we look at some of the internal passageways on the 1911, all this needs kind of cored out in order to accommodate where the safety on the beaver tail swings up out of the way to allow the trigger bar back. And on top of that, there's that disconnector hole we talked about, and then the slot for the slide stop. And then you have things like this slot here where the sear and the hammer ride. It's not terribly deep, but when you look as your holder is getting close to the back of the pistol, it suddenly becomes a problem. If we jump over to the 2011, we see that area that was cleared out for the beaver tail and safety, well, now it's just a counterbore. The counterbore for the disconnector, very easy to machine all of a sudden. And you just have all these elements just become much, much easier. And you do that enough times over this, and it really adds up into just being a delightful project. So I was able to use a stock library tool to come in and cut that counterbore then, instead of having to set up a custom drill. And then that very same tool, I believe, cut the notch for the slide stop. And I think it even did the vertical impact surface here. So when we compare this to this, huge difference in manufacturability. Another thing that turned out to be a lot easier, and this isn't strictly a 2011 thing, but so on the 1911, this is called the vertical impact surface. It's where the barrel stops as it cams back to have another bullet loaded in. Perhaps I could show that in better detail in person. So the top of the barrel would stop up against this. It'd be slightly askew up, and then when the slide came forward, it'd strip a bullet out of the magazine in, and then the barrel would use the link pin and the ramps and would come up into battery, and the slide would close on the round. But as we can see looking at it on the 1911 with classic barrel format, we got to get a tool all the way down in there to cut that flat bottom. And you really need that to be pretty precise. I'm trying to hold about 5/10 tolerance on the location of the vertical impact surface. So on my 2011, I went with what's known as a Clark cut barrel, and it stops on these radii. And as you can see, those are vertical now, and so I could use that same tool to get in here and cut that feature. And the work holding, the 2011, we used a very elaborate work holding system, And on the 1911, I'm just using my standard dovetail system on the Aroa. So it all adds up to being much easier. The one thing that did kind of stink is the dust cover on this is very long, 100 millimeters. And then you have this relief here for there's a round section on the recoil rod that needs kind of nestles in there. Getting that cut wasn't fun because it's so deep in there. So I think next time I would redesign that so you can get in there with a lollipop end mill, just so you wouldn't have to hang a tiny tool all the way down in.